Hi guys, I just thought I'd come back to this recurring decimals thing and see if we can change some harder ones to fractions. So let's say if we had 0.13 recurring. Now what that means is 0.1 and then the 3 is recurring. So I'm going to call that my x. So if x is that, last time we looked at what 10x would be, and that would be 1.3. Now, when we look at that one, we haven't got the same decimals, so we can't subtract them because they're not the same. There's a 1 and a 3 there. But if I looked at 100x, and I got 13.3 recurring, you can see that between the 100 and the 10 ones, there is the same decimals. So if I subtract those two, all that decimal point, all those decimal places will all disappear. So I've got 100x take away 10x. Now if I look at this, I'm going to have to do 13 take away 1. So those bits will disappear, but the 13 take away 1 will still have to be there, so that's 12. So 100x take away 10x is 90x. That equals 12. So dividing both sides by 90, I get x equals 12 over 90, which clearly they're both in the 3 times table. So x divided by 3 I get 4, and divided by 3 I get 30. Looking at an even more complicated one, if we were to look at 0. So let's go for 4, 3, 2. Let's push the boat and let's go for 0.1432. So if I look at 10x, I get 1.43232 because the 3 and the 2 are the bit which they're recurring. If I look at 100x, I get 14.323232. Still not the same. If I look at 1000x, I get 143.2323. Oh, still not the same. Maybe if I look at 10,000x, get 1432 and then 0.3232, etc. So what I end up with is these two here with the same decimal bits. And that's the key thing that we're after. 323232, 323232. Those bits are the same. So I'm going to have to do 10,000x take away 100x, and that's equal to, well, it's getting quite complicated now. I've got to take this away from that. I know that the decimals have disappeared, but I'm just going to write that down for a start. 132 take away 14. So 10,000 take away 100 is 9,900 x, and 1,432 take away 14 is 1,418. So x is equal to 1,418 over 9,900. Now I know that cancels down because they're both even numbers, but it's going to take me a long time to do otherwise. So back to my trusty calculator. I'm going to hit the fraction button. 1418 over 9,900 equals Oh, they only do divide by 2, that's all we could get. 709 over 4,950. And if I want to convert that to a decimal, 0.14 and 32 with the dots on, so I know I'm right. So when we looked in recurring decimals 1, we were always taking away the x every time to make it disappear. But now we need more thought. We've got to go on so that we're looking at what stage do the decimals become the same when I keep multiplying by successive powers of 10. So here the 100 and the 10 gave me the same decimals, so I could subtract them. But on this one I had to keep going because the x, which would, what would be here, started with 0.14. This one started with 0.4. This one started with 0.3, so none of those were the same. This one started with 0.2, again definitely not the same. When we came back to this one, when we times it by 10 4 times to get 10,000, you can see that I got the 3232 and the 3232 3232, and that allowed me to then do the subtraction, and these decimals would have the decimal bits disappear, which is nice, and that's what really makes this a cool piece of maths and one of my favourite things actually. So hopefully you enjoyed that, and hopefully you'll enjoy the more challenging questions. Okay, thank you.